All right. What is a radian? Oh, let's just start there. The radian measure of an angle theta, remember, is the arc length S, they're calling it, of the associated arc. I love how every book says a different definition on the unit circle. Remember, unit circle has a radius of 1. So you've got this unit circle. It has a radius of 1. You have theta being the angle, and this S is your arc length, which is known as your radian, okay? Your arc length, S, and we measure it in radian. And we do that because it's just a little bit easier now, surprisingly enough, which I know some of you still think it's not easier, but it's just a little bit easier to do everything in radians when we're at this level now in calculus. Degrees was something you could get your mind through because you've done degrees for so long, but now you got to kind of switch over back to radians. And the conversion factor is as follows, okay? So pi, let's say the conversion factor, just like good old chemistry when you use conversion factors. Pi is your radian. That's equivalent to 180 degrees, okay? Which is the same as if I put 180 degrees and radians on the bottom. And that's how we convert. So if I want to go, and if I want to end in radians, if I'm changing from degree to radian, I use this one. I use what's on top. I want to use radians. If I want to change it from radians to degrees, I use this one, okay? So radian to degree, you use this one. Degree to radian, use that one. To be honest with you, I never remember that. I just know whatever I want to get rid of, I want it to cross off, like the units part to cross off. So cool thing is, first part of your homework is you just have to convert from either degree to radian or radian to degree. So let me just give you a few here. 225, negative 60, 5 pi over 3, 11 pi over 6. Okay, and just to show you how to do that real quick. So going from degree to radian, you're going to multiply by pi over 180. And you're going to reduce this. You can put it in your calculator. You just really don't even worry about the pi. Just put 225 over 180 and hit math frac. 225 over 180 is 5/4. So this is just 5 pi over 4. That's what radian measure it is. 60 degrees, again, that's one of them you should actually know. But 60 goes into 180 3 times, right? So this is negative pi over 3. That's the radian measure. Now, if I'm going from radian and I want to convert it to degrees, I put the 180 on top and I put the pi on the bottom because I want the pi's to cancel. I don't want to have pi in my degree answer. So this would be 3 goes into 180, 60, 60 times 5, which is 300. Same thing, 11 pi over 6, you just multiply by 180 over pi. Your pi's cancel. 6 goes into 183, 30 times 11 is 330. So easy stuff. You just convert from degree to radian, radian degree, multiply by pi over 180, 180 over pi, okay? And now for the thing that I just passed out to you. The 6 trigonometric functions on a unit circle. And you are going to want to, obviously, to the best of your ability, look at this, memorize this, love this. Okay. And I will fill this out with you right now. Let me get a different pen just so I can make sure. It all stems from a right triangles, and it actually stems from the 30, 60, 90 triangles and the 45, 45, 90 triangles. Okay. So just to show you, I'll just do this one right here. Okay. This would be 60 degrees. So 60 up here. And this would be your 30 degrees. And then again, if your radius is 1, so if this is my unit circle, so this has a radius of 1, that is your hypotenuse. And again, for those who don't remember geometry, your hypotenuse, the shorter leg is half of the hypotenuse. What's half of 1? 1/2. That is your x distance, is that not? So this would be 1/2. This long leg is equivalent to your short leg times the square root of 3. So 1/2 times the square root of 3, another way to write that would be √3/2. And then you would build up your 45, 45, 91. But for time's sake, I'll give that to you. This is pi/4. This is √2/2, √2/2. The 30 degree one is, you can see it's the flip of what I just wrote up there. 30 degrees in radians. Anybody remember what that is? Pi/what?
6.
Yay, good job. Okay. Once you get this, oh, and then let's do this one right here. This is 90 degrees, and this is pi/2. And on a unit circle, so this is length 1. How do you write this coordinate right here? 1, 0 or 0, 1? 0, 1. Okay. Once you get this quadrant right here, all other quadrants, they all follow the same pattern. Okay. So I've done this before and with you guys, I believe last year. The way I do it is I kind of draw these like rectangles almost. All these points right here will all have the same coordinate. They just might flip-flop negative or positive. Okay. I don't know how Belky taught it to you guys, but that's just how I do it. So like this one would have the same coordinate, 1/2 √3/2. This one down here would have 1/2 √3/2. And then this one over here would have 1/2 √3/2. The only thing that would change would be the signs. If this is my x-axis, which one of these is positive and which one's negative? The x is negative. Down here, you're both negative. Over here, just the y. Okay. Another phrase to remember is all students take calculus, not a set of Sharon takes cocaine. All students take calculus, and what that helps you out is to remember that in this section, all of them are positive, both the x and the y. In this section, only the sign is positive. Which one is the sign? Do you remember? Is it the x one or the y? It says it right up here, actually. Your y is your sign. Your x, it goes in alphabetical order. Think cosine, C comes before S, Y, X, Y, okay? So only the sine and its reciprocal function, which is cosecant, is positive. Sine and cosecant. In this one, tangent and cotangent are positive. And over here, cosine and its reciprocal function, secant, are the positive ones. But anyway, just try to fill these out as you go around here. So, keep it going. Let's see. I don't want to spend too much time here, but 0, -1. 300 degrees because you're 30 more. And you are at then 5, because it's 5 times 60, 5 pi/3s. This one is 315, which is 7 pi/4. 330 is equivalent. We just did that one, 11 pi/6. I think I went all the way around, did I not? Beside that big boo-boo here. Good Lord, woman. All right, this is your best friend, okay? Again, your x is your cosine, your sine is your y. Your x is your cosine, your sine is your y. And so from this, and I do want you to write this down. We didn't do this a lot last year, but just some 6 trig functions. Your sine of theta is always your y. Your cosine of theta is always your x, okay? Your tan of theta, do you remember what tan is equivalent to? Tan is what over what? Sine over cosine, which is actually, another way to write that would be your y value over your x value. Whatever your y coordinate happens to be over your x coordinate. Which means then your cosecant is actually the reciprocal of your y value. So it's 1 over y. Cosine's reciprocal function is secant. That would be then 1 over x. Tangent's reciprocal function is cotangent, which would be then x over y. So some books write this, and that I think that could be helpful for some of you, because some of you don't like doing it one way or another. So this might be just a better way. I don't know. I don't ever use this. I only use this one. I really rarely use these. I just use my x and y and then kind of go with that. All right. So from there, now that you have your lovely unit circle, let's see if you can evaluate. And you'll have to do this again on homework tonight. So let's do the sine of 2 pi over 3. Let's do the cosine, and I do want to throw a negative in there, negative 5 pi over 6. And let's do one more, the tan of 15 pi over 4. And there's a reason why I'm giving you such large numbers. I will be honest with you, in calculus, we really don't do those as much. We really just stick with unit circle and rarely have to find coterminals. Ooh, don't worry about that. So sine of 2 pi over 3, you go to your unit circle. You magically find the 2 pi over 3. Hi. And you figure out which one is your sine. It's the what? Square root of 3 over 2. Done. What do I do for negative 5 pi over 6? Do you remember? There's a couple ways to do this, so I'm just wondering how you think. Do you remember coterminal? Yes. Okay, you could go backwards right now. But do you remember coterminal? You add what? 360 or 2 pi's. If I add 2 pi to this, 2 pi is equivalent to, if it's a denominator of 6, would be equivalent to 12 pi over 6. Wouldn't you agree? What's 12 divided by 6? 2 pi. What is negative 5 pi plus 12 pi? So why don't you instead find the cosine of 7 pi over 6? That's on my unit circle. What's the cosine of 7 pi over 6 on my unit circle?
210.
But what's the cosine? What's the x value? Negative root 3 over 2. There you go. Okay. So I never like to work with negatives. I always add what's called a coterminal. Okay. See, but here, this is way too much, right? 15 pi over 4. So I'm going to take away a coterminal. I'm going to take away 2 pi. But really, when I take away 2 pi, what am I really taking away if it has a denominator of 4? 8 pi over 4. So what's 15 pi minus 8 pi? So what is the tan of 7 pi over 4? Well, if I go to 7 pi over 4, right, yeah, tan right here would be, oh, look at that. I didn't even put a negative. Look at Mrs. Setta. Call her a moron today. This is why she needs the tat. This is why she needs the tat. So you would take your x, your y value divided by your x. So this negative square root of 2 divided by positive square root of 2 is negative 1, okay? There's a lot of other ways. Do you remember me doing that chart with the 1, 2, 3, 3, 2, 1, over 2, over 2, over 2? I mean, that's another way to do it, but I think the unit circle is your best thing. All right, oh my gosh, we're running out of time, and I know, so I want to finish this. Do you remember, though, your true 6 trig functions, because you are going to have to do these part, 6 trig ratios of sine of theta is your O over H. What do I mean by that? Your what over what? Opposite over hypotenuse. Okay, what was cosine? So ka.
Adjacent over hypotenuse.
Toa. Opposite over adjacent. Okay, those are your basic 6 trig ratios that you should remember from like literally 9th grade Tabby Langley. Come on now. And then if I ask you for the reciprocal functions, you would have cosecant of theta would then be, the flip of this. I really don't even write, HO, but I'm going to just for the sake of it. This would be the H over A, and cotangent would be the A over O, okay? So we're gonna do one of those problems and one more, and we're done. And then and that's it. This is literally easy peasy stuff that you did. Let me write the problem out, and you go. You guys got this written down, right? Good. You're doing so good. All right. A house painter wants to lean a 20-foot ladder. I'm literally going to abbreviate. Lean a 20-foot ladder against a house. I know. How many times have you done this one, really? If the angle between the base of the ground and ladder is 42 degrees, how far should he place the ladder? How far to place ladder? You will have one of these for homework tonight. I just want to make sure we refresh this. I know you're in calculus. I know you're like, Miss come on now. Just know how to do it, okay? But really what you do is I always give myself a little picture. Here's the house. Here's the ladder. Okay, the ladder is 20 feet. Here it's leaning. We were also told that it makes a 42-degree angle with the base. So where do I put 42 degrees? Up here or down here? Down here, okay? It's really important you know where to put those. And you are asked to find how far to place the ladder. So am I finding the bottom or the top? Okay, so we'll call that X. If you are standing here at the angle, how are these two related? Is it a sine, a so, a ka, or a toan? It's a ka. It's adjacent and a hypotenuse. So you would write the cosine of 42 degrees equals X over 20. Make sure your calculator is in, right now mine is in radian mode. As you can see that, you have to change it back to degree. And the way to do that is hit mode, degree. And then you would just solve, you multiply by 20. So it's 20 cosine 42. You can leave your answer like that. But the exact answer would be, well, let's see, 14.86. That's how far he would have to move it. Okay. And then these are my favorite ones that my students get wrong every year. And we did this last year. Oh, we did it. Okay. Last example. Point P is on the unit circle. Find the missing coordinate of the trig function. Find the missing coordinate and the 6 trig functions. And this is what you'll have for homework tonight, and this is your last problem. No, it's been a while. Oh, this is a 21-minute video. It's going to be fun. Sorry, Jimmy. Oh, and there's one more piece of information. I like this one. Point P is on the unit circle. You have to find Y and all those 6 trig functions. So let me just explain some notation to you because I don't want you to get freaked out yet. If Y has to be less than 0, what does that mean Y is? Negative. Do you all agree? Okay. If your X is negative and your Y is negative, could you tell me what quadrant I'm in right now? You have to be in quadrant 3 if both of them are negative. Do you agree? So you're going to go down here. You're going to draw yourself a little right triangle. Okay. This is the point, negative 15, 17, comma, something Y. Okay. But here's another thing we know. Since it's on the unit circle, what is this? Sine, cosine, tangent. What is this? What is the x value? Cosine. Oh. Did you see how much you just got from just this little brief thing right here? I know I'm in quadrant 3. I know I'm negative. I know that the cosine of theta equals negative 15 over 17. Just from that right there. Okay? Why is that helpful? Why is that helpful? Because now I have a right triangle and I can label my parts right now. Cosine is what over what again? So ka. What is it? Adjacent over hypotenuse. So I know that my adjacent side, which is right here, is going to be 15. I know my hypotenuse is 17. And then I know that the top has to be negative. So I can easily find this using Pythagorean theorem, can I? I think it's an actual triple one. It is one. 8, 17 15, 17 is the other one. Actually, be careful here. It's not 8. If I'm going down, it has to be what?
Negative.
Okay. So now we're almost done. Now we're going to find the 6 trig functions. Sine of theta, cosine theta, tan theta, and then we're going to reciprocate them. Cosecant, secant, cotangent. Okay. I already know the cosine. It's negative 15 over 17. I already know it's right over here. What's sine then? If you're standing here, what would sine be? What's your opposite over your hypotenuse? Negative 8 over 17. Which then just reciprocate it and you'll get this guy. Negative 17 over 8. Negative 17 over 15. Okay? And now what's your tan? Tan is what over what?
8 over 15.
Opposite over adjacent. And cotangent would be 15 over 8. And again, according to all students take, not a set of Sharon takes cocaine, tangent should be positive. And isn't that what we got out? Okay. One more thing though, what was my y value? What was it? Which one up here is the y value? Oh, yes, you're right. I'm sorry. I thought you said 8 over 15, and then I'm like, she said 17. Yes, very good. It's your cosine. There you go. I like this question. I think this is a difficult question. All right, sorry about that. Good job, y'all. So here's what you got to do. You got homework to do on this. You got studying to do on this all. And you're leaving shortly, so whatever, you want to take a break, enjoy. Let me stop my movie in a minute.
Huh?
Yep.
There's no hot day right running. Mm-hmm. Yesterday snowed bad, wasn't it? It was so hot and hurt.
Oh, I gotta stop my recording here. Our good buddy Jimmy.